kind of invert it outward and see what makes it tick. What is it thinking about? What are the important parts of the image? And if you look at that, maybe if you squint, you see that it's a face. And you can see the areas that are lighter are more important. And so areas, you know, in the bottom aren't that important, but the mouth is really important, and the ocular region is really important, as well as the shape right here. And then we can take that algorithm that I mentioned from 2001, the Viola-Jones algorithm. We can take that and do the same thing. We can invert it. We can bring out, evoke the ghost in the machine. And the face that's hidden inside that profile looks kind of ghoulish, but it looks like this. And there's a front and there's a profile angle for that. Now I think it is where it gets more interesting and hopeful. So now we can analyze that algorithm and we can figure out where it's vulnerable. And we can see that in this example, areas that are red, yellow, and green are more sensitive to variation, whereas the areas in blue have more, they're more tolerant. So we can use that information to appear in a new way amidst these new ways of being seen. So I want to then present some of the work that I've done with camouflage, but preface it with this idea that camouflage used to be a not very cool thing. In fact, it used to be what you would call a criminal. Camouflage was a term for criminals hiding from the police. And that was a long time ago, in the early 1900s. But it was Theodore Roosevelt who considered camouflage as an effeminate form of cowardice, a mere defensive strategy that all but announced an unmanly desire to hide instead of fight. And as World War II continued into its 6th year, camouflage finally evolved into the way that we see it now, which is more of a sign of intelligence, a sign of outwitting your opponent. So if we can, we're going to look past this M81 being able to blend into the background of a jungle and think about new ways of appearing, because even with all this camouflage and face paint, a computer can still see that there's a face there. And this is another example of what I described as the saliency map, which tells you, what the computer is seeing. So these are 2 examples of a camouflage project that I've worked on, which gets at exploiting those small vulnerabilities in the algorithms and then creating art out of it. So these hairstyles and the makeup, they're designed in a way where they kind of invert what the algorithm wants to see there. So if the algorithm wants to see gradient going, this way, then you invert that. And if the algorithm wants to see a light region in between the eyes, the nose bridge, then you cover that with some hair and so on. And so by understanding how you appear, you can begin to modulate your appearance. So if we look now at that same visualization that shows us what the algorithm is seeing, there are no faces. So compared, you can do that and still be seen, or you can do that and not be seen. And let's see, and in that one, it doesn't work as well, but it works 4 out of 5 profiles. So this is another example with a few more specific tips. If you're interested in creating a look, then you can think about creating asymmetry, because these algorithms expect a face to be symmetrical. You can integrate asymmetry into your appearance, into your fashion styles, into jewelry, into hair accessories, and invert those features like the light spot on the nose, and partially occluding the eye region. This is a short demonstration where on the left is the model before, and on the right is the model after. And the computer vision is running the same program on both of them. And what you'll see happening is, where it's taking longer, it's more likely to be a facial area. And it'll, maybe I'll skip ahead a little bit. So you can see eventually, there are a lot of positive markers over the face on the left, and there's only one on the right. And while we like to think of camouflage as something that makes you indivisible, like a Harry Potter cloak, really that's not how a useful way to think about camouflage, where even if you do have an invisibility cloak, you can't destroy matter. So matter has to be shifted. It still exists in some form, and you're only shifting visibility between those forms. The idea, of course, is to shift the visibility away from the observer and shift it into an area where no one is observing. So you can see by the end, having only one mark means that it's not, you have to have at least 3 overlapping. And on the left, there are like 20 overlapping. So face and no face. And you can ask me and I can tell you more, specifically about how that's being implemented. Then, if I have a little time, I'll keep going and talk about one more project. So, as I was saying, you can shift from one, say, spectrum to another. Invisibility is specific to the way that you're being observed. If I'm looking at you with a thermal camera, I'm going to see, I won't see the colors that you're wearing, I won't see all the effort you put into putting together an outfit. What I will see is areas of you that are hot and cold. A thermal camera only looks at heat. And actually, it's very easy to see somebody because everybody gives off approximately 100 watts. Like an old incandescent light bulb. So you're emitting that energy, which means that unlike a visible wavelength camera, you don't need to be illuminated. You are the illumination, which means at night, a thermal camera is a great way to identify someone. And that's why thermal cameras are used on drones, a lot of military drones in particular. And a military drone, will be able to identify at night in pitch black somebody from a very high distance because they're emitting all of this visible energy in the form of heat. So this project from 2013 looks at how do you create an invisibility cloak in that spectrum? How do you hide from thermal imaging, or can you? And through this project, I created a line of clothing called stealthwear that's inspired a lot by Islamic dress, the burqa and the hijab, and turned it into an anti-drone line of clothing. So you could wear these items, and as you see, you can make parts of your body disappear to a thermal imager. And it's a direct statement about the ways that military drones are used. As someone who does not work in the military and nor understand the mentality of people in the military, I released this project without really being sure what would happen. And to my surprise, it ended up being tweeted by the Pentagon. So it had gone all the way to some art and fashion blogs, which I'm more comfortable with, to the New York Times, and ended up on the front page of the Air Force Times and on the Pentagon, so in their Air Force General Council Twitter feed. So some of these things have, they're not just prototypes. I think as an artist, I'm interested in making things that work, you have to deal with them. You can't just think about what would happen if somebody made this. It's made, and now people can do it. People can buy it, I put it up for sale, or people could make their own. But the idea is out there. And something I'll talk about more during the week is how do you convince somebody that camouflage would be worthwhile to wear? Because that's a lot of work, and that's not really appropriate for every situation. How do you think about the appropriateness and the social norms around camouflage and what might be acceptable for certain situations, how to maximize, to put it like in economic terms, how to maximize the control of your visibility, and minimize how much you stand out or how much you separate yourself from other people in doing